He is considered by many to be one of our greatest living scientists and certainly our best known. For the past 30 years, in fact, he has held the post once occupied by Isaac Newton as Cambridge's Lucasian Professor of Mathematics. For his entire career, he has dedicated himself to the study of the basic laws which govern the universe. With Roger Penrose, he showed that Einstein's general theory of relativity implied space and time would have a beginning in the Big Bang and an end in black holes. These results indicated it was necessary to unify general relativity with quantum theory. The search to discover this so-called theory of everything has been the driving quest for physicists for the last quarter century. Hawkins says that this unified theory could, quote, help answer some of the ultimate questions about the universe and our existence.
He would certainly rank as one of the people who've done most to extend our knowledge of gravity beyond what we had in the time of Einstein. So he's one of the great figures in our understanding of gravity. The fact that he is the world's most famous physicist is, of course, not only because of his physics, but because of the way he has striven against the odds and the way he has engaged with the public and the way he has been an inspiration to people far beyond science.
You look at his work beyond, as you said, gravity and the black hole and investigations into that. What will he be best known for?
I think he will be known in the history of physics for some important work he did mainly in the late 1960s and the 1970s in understanding the nature of black holes, the nature of the Big Bang, and in some really pioneering ideas on how we could relate to previously unrelated branches of science, namely quantum theory and gravity. He had a very important idea about black holes and how it relates to quantum theory, which has been the subject of much discussion over the 30 years since that time.
In fact, he has written about and talked about the pursuit of the theory of everything, which is combining with quantum mechanics and at the same time gravity and the theory of relativity.
Yes, well, that is, of course, still an elusive goal, and many other people, especially those who do so-called superstring theory, are working on that, and we don't know if that'll pan out or not, but certainly we all know that it's important to unify these two basic ideas in physics. The 20th century gave us Einstein's theory of gravity, it gave us the quantum world, but there's no way of unifying the very large and the very small, and that's one of the challenges, the unfinished pieces of business for the 21st century.
If we reach that, what have we done? What have we accomplished?
Well, that's an important question, because we will have reached the end of a chain of progress that goes back to Newton, who told us that the force that holds us down on the Earth is the same that holds the moon in its orbit and that makes the apple fall, and which went on through other great scientists who unified the different forces. So it will be the end of a very important progress in science. But I think the phrase theory of everything is slightly hubristic and misleading, because it won't really help most of the rest of science. If you're a biologist or indeed a chemist, you're not held up in any way by the fact that we don't have this so-called theory of everything. What is the challenge to most of science is that things are very complicated.
But do you believe there is a single theory of the universe that will show us how everything fits together and how it all, why the universe and why it works and why? Well,
I think there may be a theory which is a linkage between the very small and the very large, which gives us a deeper understanding into the forces of nature, the size of the universe, and the kind of particles and atoms that exist in the universe. I think there will be that. But once we have that theory, that's not the end of science, it's the end of one phase. But we still have the challenge of another frontier of science, the very complex. We'd have linked together the very large and the very small, but the very complex, especially the living world, faces us with deeper challenges. And I think that is going to be what keeps us busy for generations to come, and indeed raises many problems which may have to await the post-human era, because we have to ask whether all these problems are accessible to our human brains or not.